Hi, my name is Sachin Takmare and you are welcome to the 15th video of this series. In the previous video, we learned how LSTM works using the cricket match story. We understood how the forget gate, input gate and output gate play important roles. However, LSTM contains three major gates and two memory states, cell state and hidden state, which are also known as the long-term memory and short-term memory. Because of this, the model becomes quite complex. At every step, many complex operations are performed, and the number of weights and biases is very high. This consumes a large amount of memory and makes the model very heavy. As a result, training becomes slower and overall efficiency decreases. Imagine that you have a smartphone. It has almost all the features camera, apps, editing tools, and gaming capabilities, but the phone is very slow and it hangs frequently. What would you want? You would want the same features but in faster and simpler device. Researchers thought, can we reduce this complexity while maintaining similar performance? This idea led to the development of GRU, Gated Recurrent Unit. GRU is a simplified version of LSTM. If you compare the architectures of LSTM and GRU, you can easily observe the difference. From their block diagrams, you can understand the complexity. In LSTM, there are two separate memories, cell state and hidden state. GRU combine these two memories and keeps only one memory called hidden state. This makes the model lighter and simpler. LSTM has three gates, forget gate, input gate and output gate. But GRU has only two gates, update gate and reset gate. Let us understand them. The update gate is a combination of the forget gate and input gate from LSTM. It decides how much information should be carried forward from the past and how much new information should be added. The second gate is the reset gate. It decides how much of the previous information should be ignored. In simple words, it determines how much information from the previous memory should be used. Think about attending a lecture. You remember the important points explained by teacher and ignore unnecessary information. The reset gate works in a very similar way. GRU is considered an alternative tool for LSTM. Both LSTM and GRU are powerful architectures. Now, an important question arises, which one is better? The answer is, it depends on the situation. There is always a trade-off between LSTM and GRU. Let us understand this with an example. Imagine you need to travel from one place to another place. You have two options, a car and a bike. Which one will you choose? Again, the answer is, it depends on your requirement and the situation. If the journey is long, you are traveling with your family and you want comfort, you will choose a car. But if there is a heavy traffic, you have limited time, your fuel budget is low and you want to reach quickly, you will choose the bike. Exactly the same idea applies to LSTM and GRU. Both architectures are powerful. The choice depends on the problem you are trying to solve. If your problem is complex and contains long-term dependencies, you may choose LSTM. If you need faster training and have limited computational resources, you may choose GRU. In AI, there is a popular saying, there is no best model. There is only the right model for the right problem. Therefore, whether you choose LSTM or GRU, the decision depends on your use case. and availability of resources. As we discussed earlier, LSTM was introduced around 1999 to 2000. GRU was introduced in 2014. After 14 years, it took almost 14 years of research to develop GRU. Interestingly, in the same year, another important architecture was introduced. It was called encoder-decoder architecture. This architecture produced revolutionary results for sequence to sequence data. We will study this architecture in detail in the next video. But before that, let us understand what sequence to sequence data is. In previous video, we discussed tabular data, grid data, and sequential data. Tabular data refers to data organized in rows and columns, such as Excel sheets or database tables. ANN works best on this type of data. The second type is grid type of data, which mainly includes image data. Images consist of pixels arranged in two-dimensional grid. CNN works best on this type of data. The third type is sequential data. In this type of data, the order of information is extremely important. Examples include sentences, speech, time series data, etc. If the order changes, the meaning can change. For such problems, we use RNN, LSTM, or GRUs, depending on the requirements. Now, let us discuss another important and interesting type of data, that is sequence to sequence data. In this type of problem, the input is sequence and the output is also a sequence. The best example is machine translation. Suppose we want to translate the English sentence, I am very happy to see you, in Hindi. The output could be, तुम्हें देखकर मुझे बहुत खुशी हुई. Here, the input sentence is the sequence and output sentence is also a sequence. The number of tokens in the input and output does not necessarily have to be the same. They can be different. Similarly, speech to text, text to speech, question and answer systems, chatbots, and text summarization are all examples of sequence to sequence problems. Handling such tasks effectively using RNN, LSTM, or GRU was difficult. Researchers continue their work. In 2014, three researchers from Google, Iliad Sutskever, Oriol Vinglias, and V. Lee, published the research paper titled Sequence to Sequence Learning with Neural Networks. Today, Ilya Sutskever is known as the co-founder of OpenAI, the company behind ChatGPT. In this research paper, they introduced an architecture called encoder-decoder architecture. The journey that started from this single research paper eventually led to modern AI systems like ChatGPT. In the next video, we will discuss this research paper and the encoder-decoder architecture in detail. Friends, if you would like to continue this storytelling series, Neurons to ChatGPT, the complete journey from Neurons to ChatGPT, stay connected with me. Follow and subscribe the channel and share this series with your friends who are really interested learning AI. I will see you soon in the next video of this series. Thank you for watching this video. Bye.